All right, here we go. Just a quick recap. What did we do yesterday? It all revolved around solving quadratic equations. Okay, so maybe go back to 20 when it comes to solving quadratics. Okay, there's going to be two methods. I'm going to just highlight that part here. On page 20, there are two methods of solving quadratics. And here they are. On page 20 this is, right? There are two methods of solving. One is using the quadratic formula, which we practiced yesterday. And the next one is what we call a graphing method. Don't worry, you won't have to actually graph it. You graph it on your calculator. That's what we're talking about. Okay. So let's go over to page 22 and start that process. Okay. So this is the graphing method here. You're still doing the same thing here. We're finding the x-intercepts. Okay. And I do put it down if possible because it could be that your parabola never crosses the x-axis, in which case, see the connection here, in which case the graph would never cross the x-axis, right? Your quadratic formula, if you were to do it, you would get a negative inside the root, okay? So that would be mathematically on paper how you could show it. So everything, you should see a connection between everything we're doing here. Regardless of how you would approach it, that you would find out that there are no x-intercepts if it never crosses it, okay? Note that if lines do not touch, there is no x-intercept. Okay? So there are two options here. I will let you choose every single time what option you prefer. Right? So you've got option 1, option 2. Option 1 you'll be very familiar with. Just like before, remember you're trying to find x-intercepts, so let y equals 0 if present. Rewrite the equation in general form. Essentially, this is combining like terms. Okay, combine like terms. Then enter the left-hand side into y1 and the right-hand side into y2. And then we'll just go second trace 5 to find any and all x-intercepts. So this method, option 1, you end up with ax squared plus bx plus c is equal to 0, because normally we have a y on the other side, but you've let it equal to 0. So that's what you're going to strive towards, which is exactly the same thing we do when we're trying to use the quadratic formula. So it's the same thing that you're doing up until the solving part. Option 2, let y equal 0, same as before. Enter left-hand side into y1, right-hand side into y2. No rewriting necessary. That's what I'm going to, with option 2, there's no rewriting necessary. You keep everything as is. Okay? That's what I prefer, the second option personally, but you might have to play with your window a bit more when you do that. Okay. Then use second trace 5 to find any and all x-intercepts. So a lot of things are similar except for you don't rewrite here. But remember, this is important for this second option. Okay. I'm going to use a different color for that one, maybe orange. That's a big note for option number 2. You must state your answer as number 0. And this is what I'm trying to tell you here. Example. The intersection, write this down because when you review, this is going to be a good reminder. The intersection between, so I'll just go between like this, okay? Between two lines may be 1.37, 4.39. It may be. That's just an example. Because you'll find the intersection between the curves. That's what you're doing here. You state, right? You state it as 1.37, and I'm going to use a different color for the, you basically drop this part, the y part. You're just going to call that 0, okay? So you're essentially, you got to just make sure if you do this method that you don't forget that the y is 0, okay? With the other ones, you don't have to worry about it. And so here we go. I'm gonna start with on this one here. Notice what it says. I don't know, for some reason I get a lot of blanks. Not a lot, but more than I would like to see. If I asked you to solve, I'm going to use a different highlighter, solve the following using, it could say the quadratic formula, but in this case it says using a graphing method. Okay, that's, so you choose how you want to do this. Let me show you option number 2. Okay, basically what I do is I leave everything as is, and I type this one into my y1, and I type the right hand side into y2. Okay, this is what I would call the left hand side. This is what I would call the right hand side. And I will actually write this down. You might have to use zoom fit, right? Zoom fit may be helpful, may be helpful. And I will do this with you. So grab your calculator. My window is completely different. Like my window is probably the same as yours. So this will be a good exercise to figuring out how to do this. Okay. So type in what are your y equals, clear whatever you have in there, and start typing. Exactly the way it appears. So, as you can tell, you're essentially going to have, sometimes you have two parabolas meeting each other, crossing each other somehow. Sometimes you have a parabola and a straight line. It depends on what I provide you with, right? In this case, we know that both sides have an x squared term, so we're expecting two parabolas here. So let's hit graph. Let's see what we get. Not very good for me. I don't know about you. But I'm going to try zoom fit. It does a pretty good job. So let's press zoom. And zoom fit is option number 0. You got to go all the way down to zoom fit. There it is. It's not bad. Okay. They're both pointing up, and you could probably verify that, right? If you look at both of the leading coefficients, they're both positive, so they're both pointing up. So what we need is we see one intersection there, and we're quite certain this is going to happen again over here somewhere, correct? Let me use my pencil. It's going to happen somewhere up here. So what should we change on our window? Press window. I would change probably my X max. I would change that to, I don't know, I'm going to go 50, right? I'm just making stuff up, right? And my Y max, it's 3,800, so 7,000. If you wanted to go 5,000, that's fine too. You try it. And now I'm going to hit graph. So I've increased the X max and the Y max. And and it was overkill. It was overkill, but I can see that it's crossing here and here, and that's all I need, right? This is good enough. So let's go ahead and press second trace. You need to show me this at the very minimum, right? And intersect is option number 5. That's why my notes show second trace 5. So let's press second trace 5. Oh, this is also a good instance. My cursor is not on the screen. I don't know if yours is. I go sideways, I don't see it. So you go by these coordinates. If you go to the right, I see that my y is increasing. So I'm not going to see it if I keep going to the right. I'm going to go left. Keep going left, keep going left. There it is. Because as I kept going left, I could see the y dropping. So I know it's coming towards me. Okay. So anyways, which one would you want to find? I'm going to find this one first. So go close to it and then just hit enter 3 times. 1, 2, 3. And here's my first one. -0. Don't forget about the negatives, okay? For now, I'm going to write down the y and then show you in the notes that we need to get rid of the 59. We're going to change that to a 0. Now let's find the other intercept. Second trace 5. One more time. I'm going to go closer to the other one and just press enter, enter, enter. And I get 1362, 5,779, right? So 13.62, 5779.43. I want to talk about the cursor not being there because sometimes that throws students off big time. Okay, so let me make it disappear. I'm going to go second trace 5. I'm going to make it go outside my window. So let's say you have no idea where it is. I just keep pressing and holding it, okay? So now it's like way out there in La La Land, right? Just go second trace 5 and just press enter 3 times and see what happens. It could be that it just appears on your screen. So I'm going to do that. Enter, enter, enter. See, it showed up there. Because, you know, it's far up here somewhere. But it will say, well, this is the closest intersection to wherever you are out here. So it's going to boom, it's going to find that point. And then you just have to go second trace 5 one more time and just go closer to the other one and then you find it, right? So be creative. If you feel like you're stuck, you're not, right? You know a lot of things, you can try things and troubleshoot, right? Troubleshoot your situation. We cannot have this, right? We need to get rid of this. So this is how you would state your final answer. That is the one thing you need to remember if you want to use this method to not. Because if you don't put a 0 here, you actually don't get the concept. Okay, that's basically how we see that. So you gotta watch out for that. Now let's use method. This is option number 1 that we did here. Option 2 I used here. Now I'm going to break this down here. I'm going to cut this. This is going to be option number 1. I'm going to rewrite it quickly here. Okay, I'm rewriting the whole thing here. And now I'm gonna do option number 1, which is rewriting the whole thing, combining like terms. Essentially the same thing as what you would do if you wanted to use the quadratic formula. Okay. Fun stuff, eh? All right. This I'm gonna leave. Okay. So I will go 32x squared minus 15x plus 50. You got to show me every line what's happening, right? So this 2 will distribute out. So it'll be 12x squared plus 125x sorry, 250x plus 150. And so I have a lot of times students rush through this and they make a tiny little mistake along the way and it just throws everything off. So take your time, especially when you're foiling out or when you're distributing. Make sure you get it right. Now I'm going to bring stuff over. So I'm going to bring the squared terms over to this side. I'm going to bring my x's over to the other side and my constant also over to the other side. So they're all terms. It's almost like chunks and blocks, right? So we're going to go 32x squared. The 12x squared is positive on this side. It comes over subtracting. I don't know if you want to use a different color. It doesn't hurt. And then I have the negative 15x already on the left side. Nothing happens to it. But this 250x will change to a negative. It's not always, right? If it had been negative on that side, then it comes over positive, right? Plus 50, and then minus 150. And all of that is equal to 0. Okay, so now we have 20x squared. This would be negative 265x. And this would be negative 100 is equal to 0. And now we basically, watch this, we do the same thing as before. We do put this into y1 and this into y2, and you will realize, wait a minute, we did this before. When y2 is equal to 0, we're finding x-intercepts, correct? Yeah, you bet. Second, trace, intersect. And I'm not putting zoom fit, but it may be necessary. Okay. Think of it this way: if you don't see your graph, you're like, hey, my calculator is throwing a fit. Oh yeah, zoom fit, right? Something like that. So clear everything. Let's type that in. Now, you should get the exact same answer. If not, we're in trouble. Something went wrong. But this is a way to confirm that what you're doing is right. So type in the top, the left-hand side, type in y2 is equal to 0. I'm going to hit graph at this point. And the window still works, so that's nice. It doesn't always. And so basically we just find the intersection between those two lines again. So second trace 5. I'm going to find that one because it's there. And lo and behold, you get the same answer, right? The first intercept is the same, second trace 5 one more time. I'm going to go over to the left side. And so that is negative 0.370, just like our other one that we had on the left side. So option 1 involves rewriting. Option 2, no rewriting. So they both have pros and cons, right? No rewriting means often that it's a little uglier. Finding your window may be a bit more work, but zoom fit does a pretty good job at helping you out. Okay, so if we had used the quadratic formula, we would also get the exact same answers. Okay, guys, so quadratic formula and this method, they all allow us to find our x-intercepts. These are solutions. These are our roots, our x-intercepts. They all mean the same thing. Okay, all right. Why don't you, I'm going to ask you, let's go over here. I assigned 24, correct? Using the quadratic formula. And 25. You know what? I will ask you, go to 25 here. Or do I have one like that back there? How many of you did finish 25 completely? Good, good. I like that. Don't stop. Then I'm going to keep going to 28. Let's go to 28. Looks like this. I'm going to ask you to try this one right here. I'm going to ask you to solve by graphing using technology, either option, right? Either option 1 or 2. It's up to you. So I'm going to ask you to do that. That's going to be your first step, to just find the x-intercepts using your calculator somehow. And then the second will be verify using the quadratic formula. So technically you have to rewrite it anyways. So you might as well just do it. Might as well rewrite it. Like I would say, do option 2 first, where you go y, this goes into y1, this goes into y2. Find those two intercepts, then rewrite the whole thing. Find the intercepts again with your calculator, then use the quadratic formula to verify all of those. So all of those should give you the same answer, regardless of what you do. Okay. So I'll say it one more time. Go y1, y2 like this, and find the intercepts. Then rewrite this whole thing, bring everything over to one side, clean it up, and then verify using your quadratic formula. Okay, so let's I'll give you some time to do that. I saw consistent answers, by the way. All of you got the same x-intercept, so then I'm like, okay, you know what you're doing. You're able to find your window. So way to go. It's negative 0.410, negative 4.930. Yeah, okay. My keys are scanned, so I'll post them later on. This one, anybody tried it already? This one, sometimes you have to investigate, like if you do second trace 5 and it doesn't allow, it says it can't find a point or some kind of error, they don't cross, right? They don't meet. So this one has no x-intercepts. If you did it with a quadratic formula, you would get a negative inside the root, which we call the discriminant, right? So you could stop there and be like, no roots because the discriminant is negative. You stop there. You don't try anything else, right? So it all jives, right? The graph should tell you the same story as your quadratic formula does, right? So that's actually what we want. So I'll post so what I will tell you is this. If we go back to page 22, I'm just going to say, where could you find more practice? I'm just going to post anything from 23 all the way to 28. Okay, so let's go to page 22. And we'll just say practice at the top here, practice 23 to 28. Key posted, right? Let's go March 12th. That way you can go look up this date if you want the key. I don't know if you save the keys. I don't know what you do these days, but that's where you would find the key under today's date. Okay, so we're gonna stop there.